Hey everybody, welcome to your next lesson. We're going to cover classifying triangles today and kind of how to figure out what the triangle is called based on two things, based on its side lengths, and the other thing is how big or how small the angle measurements are of each angle. Okay, now starting right off here, let's talk about polygons here. And the first type of polygon that we talked about was the triangle. Now, triangle is the simplest type of polygon. It has three sides, and remember, polygons are only made up of line segments. Today it's going to be, okay, what are all the different ways we can classify a polygon? What are the ways we can group them? Triangles can be classified or grouped in two different ways. One way is by the measurement of their angles. And sometimes when you're looking at a triangle, you might see that there's certain markings, like this mark that I'm making right here, that represents that we're talking about the angle. And notice how I put one arc right there. Sometimes you'll notice that there's a different number of arcs. Like this might have one arc. This might be denoted by two arcs. And this might be denoted by three arcs. And same thing right here. And that just represents that we're talking about different angle measurements. So if you notice, like these all have one arc. I only used one. And these all have different ones. That just represents, well, if they all have the same measurement, if they both have the same arc, then we're talking about same angle measurements. They're congruent, which means they're equal. If they have different arc indicators there, then we're talking about different angle measurements. So classifying them by their angles is the first way. So classifying them, how big the angles are, how small they are, whether there's a right angle. Really, we're just going to be looking at whether they're obtuse, acute, or right, and those are kind of important things to look at. Next, we're going to classify triangles by the lengths of their sides, by their side lengths. And again, just like with angles, you might notice that at side lengths, there's going to be hash marks on the segments themselves. So there might be just one hash mark representing that these segments right here. So for instance, if this was, I don't know, let's say this was 5 centimeters. Well, since this has one hash mark and this also has one hash mark, well, I can safely say that these are all 5 centimeters long. Each segment is 5 centimeters long. On the other triangle, we might have one hash mark here, two hash marks right here, and three right here, which just represents that we're talking about three different lengths of segments. So again, we might have, like, this might be 7 inches, this might be 9 inches, and this might be 10 inches. And that's how that is. Now, don't always associate just the three. There's 3 marks here, there's 3 tick marks there. That means it's the greatest. I'm just doing that to show you that we're just indicating that we're dealing with different lengths. Okay, now the triangle sum theorem is something that we're going to want to go over before we get too far into this lesson. And it's a pretty simple theorem. And it states that the sum of the interior angles of a triangle will always have a sum of 180 degrees, always. And that's important. The sum of the angles are always, always, always going to be 180 degrees, no matter what. Doesn't matter what the triangle looks like to you. It doesn't matter like if something looks off on the triangle. But no matter what, the three angles, the three interior angles, this angle, and this angle, they will add up to 180 degrees every time. And that's why that's called a theorem. A theorem is something in math that has been proven to be true no matter what. Every single time it will be true. So the first example right there, we have two angles that are given, and then we have one angle that is not. So we're just going to set up a really simple equation to solve this. So x is the missing side, or the missing angle, I should say, plus 55 plus 70. And then the triangle sum theorem states that all angles add up to 180 degrees. And then I'm just going to solve this like I would any equation. So 55 plus 70 is 125. I'm going to take 125 from both sides. Those cancel out. And then we get an answer of x equals 55 degrees. So that angle right there is 55 degrees. And I think the thing that you have to kind of keep in mind is that some people they might look at the triangle and go, well, Mr. Oliver, I got my protractor out and I actually measured that angle and it wasn't 55 degrees. It was actually 63, or maybe it was like 51 degrees or something, not exactly 55 degrees. And people will argue and make a good argument, which is correct. I'll say, well, yeah, that angle is indeed what you say it is. But what we have to do a lot of times in geometry is we can't always rely on the picture. So we have to rely on the numbers, or just the math itself, the numbers. So 55, we can be pretty confident here that 55 plus 70 does equal 180 degrees. So a lot of times you have to kind of just throw out all what you see on your paper. I know sometimes, a lot of times I tell you to use good common sense and use good critical thinking. But a lot of times in geometry, especially geometry problems, they try to throw you off with angles that look bigger than they are or smaller than they are. And so you just have to rely on what the numbers, what are the numbers that they gave you. That's important. For the next example, you're going to notice that this is pretty algebraic. So I'm going to set up an equation here with all the expressions, 5x plus 2 plus 134 plus 6x, and we're going to set that equal to 180 degrees. And then we're going to set this up, we're going to solve this by putting like terms together. 5x and 6x are like terms because we're allowed to add x's with other x's. So you get 11x. 2 and 134 are called your constants, and those make 136. And then we're going to set that equal to 180. Now what we have at this point is we have a basic two-step equation. So when we have a two-step equation, we can either undo 11x by dividing by 11, or we can undo plus 136 by subtracting 136. Now, I'm not giving you a choice, like, well, you could do either one. You have to do it in a certain order. So the first thing we want to do is undo addition. Remember, order of operations gets all turned around when you're doing inverse operations. Everything gets turned around, it's backwards. So we're going to subtract 136 from both sides first. So what I have is 11x equals 44, and then the last step is going to be dividing by 11. And so what we get is x equals 4. Now the thing we have to keep in mind with this particular problem was we just figured out what x was. We didn't necessarily figure out the angle. So if we want to figure out what x is, we're going to insert that number 4 where the x is. So 5x does not mean 54, it means 5 times 4 plus 2. 5 times 4 is 20. 20 plus 2 is 22 degrees. So that's what that angle is right there. Same thing right here. We're going to put 4 where the x is. That does not make 64. It makes 6 times 4, which is 24. And if you're unsure still, like, did we do this right? You can add all those up. You can do 134. That's the angle that was right here. We've got 22, and we've got 24. And see if that does come out to 180, and it does. The first way that I'm going to talk about classifying triangles is by classifying them by their angle measurements. You have to sometimes rely on the numbers that you're given and not just on the pictures. I mean, sometimes pictures are great and they help you, but a lot of times, like I said, most geometry problems, they try to trick you, and it's not my objective to trick you. But I think the objective is to make you think about what are the numbers that are given, and not just looking at it, but we want to make sure we're, using all the information that we're given there. So you notice that all these triangles, there's like something missing. Okay, so in this first triangle, we have 2 angles that are given, and we have 1 angle, of course, that is not given, and we need to figure out what that missing angle is. So we're going to set up an equation here, x plus 54 plus 65, and we know that all angles of a triangle add up to 180. 54 plus 165 is going to be 119, and then make that equal to 180. And then we're going to take away 119 from both sides. So there's your angle measurement right there. We got 61 degrees. Now what this triangle is right here is this is called an acute triangle. Now an acute triangle has all angles, all 3, every single one of them. This angle, and this angle are all acute. Now remember, acute means less than 90. means greater than 0, of course, but less than 90. So it's between 0 and 90. So all three angles. And sometimes you're only going to be given, like I started out this problem, we only started out with these two angles right here. And you might think, well, those two are acute. That's all I need to find. Don't just assume that the third one is also going to be acute. Look it up, make sure everything works out, okay? Now the second type of triangle has a box in the corner. And in case you're wondering, whenever there's a box or a square in the corner, that is an indicator that we're talking about a 90-degree angle there. All right, so the only angle that we're not given is this one right here, and we don't want to assume what that is. We want to use good algebra here and figure out what that is. So we've got x plus 45 plus 90 equals 180. And then if I simplify this out a little bit, I get x plus 135 equals 180. And I'm going to kind of skip a step here. I'm just going to go right to subtracting 135 from both sides. And then x equals 45 degrees. So there's that angle right there. That's 45-degree angle. Now that makes that a right triangle. And it really didn't even need to figure out that third angle. But the definition of a right triangle is that just exactly, only one angle is right. It's impossible to have a triangle, if you think about it. It's impossible to have a triangle with two right angles. You know, let's say we have two right angles right there. Well, obviously, those are never going to close, so that wouldn't work out. So you want to have only one right angle in a triangle if at all possible. Okay, and the third type of triangle, we've got an obtuse triangle. And that's what we're talking about. And you might be thinking, well, we only have acute angles given, and we have an angle here that's missing. So again, we just use a little bit of algebra, and we solve this. X plus 27 plus 32, and then make that equal to 180. So you get x plus, well, 27 plus 32 is 59. Make that equal to 180, and then I'm going to take away 59 from both sides. And then you get x equal 121. The description of an obtuse triangle is that it has exactly one obtuse angle. It's impossible to have two obtuse angles. So this is a lot to take in, but we're looking for, for acute triangles, we're looking for all acute angles. Every single angle is acute. For right triangles, only one angle is right. And for obtuse triangles, only one angle is obtuse. And it's really important before you guys make any determination whether it's acute, if it's right, or if it's obtuse, know what all three angles are. Even if it looks like something you think it looks like, still go through and figure out use the math and go through and figure out what all those angles are before you start writing down whether it's acute or right or obtuse. Now the next way we can classify triangles is by the side lengths. And you'll notice that there's a lot of hash marks here written in, and I've described that earlier. So make sure you guys, if you don't remember what that is, go back and review that. But the hash marks represent that we're either talking about same or congruent side lengths or different side lengths. So the first type of triangle has, if you notice, all the hash marks are different. There's one hash mark here, there's two here, there's three there. So that represents something called a scalene triangle. Now a scalene triangle means that no two sides are equal. All three lengths are different. Now one thing I'm going to make a point of kind of talking about here too is that angles, there's a definite relationship between angles and sides. And what I mean by that is if you look at this first example here, the scalene triangles, if we have scalene triangles which are all sides are different, well, it's also safe to say that all the angle measurements are different as well. So that angle right here is going to be different from this angle, which is going to be different from this angle. And that will always be true. If it has three different side lengths, you can guarantee, I'm not just going to say bet because that means there's a chance that maybe it's not going to be that way, but you can guarantee that it's always going to have three different angle lengths. Now the next type of triangles is called an isosceles triangle. And this one has a kind of a tricky definition, and I'm going to kind of talk about that more in detail later. But the word at least, or the phrase at least two equal sides, that means a little bit more than you think it means. But a lot of times, isosceles triangle is where you have two sides equal and one side's different, but it doesn't always have to be that way. And if it's an isosceles triangle, here's another thing you can guarantee. If you have an isosceles triangle, you can guarantee that there's two angles that are equal too. And the two angles are always going to be connected to the equal sides. So for instance, like if this is 70 degrees, this is also going to be 70 degrees. So if you know that that's 70 and that's 70, well, that's 140, and that's got to leave 40 degrees for that angle. But that's always going to be true in an isosceles triangle. Find the equal sides, find those equal sides, and there you will find your equal angles as well. They're going to be at the base of those sides, I should say. And then the last type of triangle that we're going to classify by their sides is called an equilateral triangle. And you probably already know what this is, where all three sides are exactly the same length. And if that's true, so are the angles. So you can guarantee that that angle is equal to that angle, which is equal to that angle. And not only are all the angles equal, we know exactly what those angle measurements are. It's not going to be something that you have to measure or figure out by, getting some numbers. We know that this is always going to be a 60, 60, 60 triangle. Equilateral triangles are always going to be 60, 60, 60. Okay, so let's dive into our first example here. We want to classify this triangle by its angles, and we want to classify it by its side lengths. So you might look at this and go, oh, I see 65 degrees, I see 43, and you might think, oh, I know exactly what that is. It's acute, but don't assume that. Know what that third angle is. We need to know what that third one is before we actually come to that conclusion. So we're going to set up a really simple equation here. X plus 65 plus 43. And then just make that equal to 180 degrees. 65 plus 43 is 108. And then we're going to take away 108 from both sides. So there's the angle measurement that we were missing. So we know that that is 72. So that's 72. So what we have here is we have all angles. We have all angles that are, well, that's less than 90. 43 is less than 90. And we have 72, which is less than 90. All three angles are acute, meaning that this is an acute triangle. It's an acute triangle because every single angle, all three of them, are acute. So if we look at the side lengths here, we're just going to look at the measurements of every side. So this is 74 feet, this is 72 feet, and this is 81 feet. So what do we know about side lengths where all three side lengths are different? Well, that's called a scalene triangle. So this right here, what we have is we have a scalene acute triangle, or we can call it acute scalene. It doesn't matter the order in which you say it. So it's acute scalene or scalene acute triangle. It's scalene because all the sides are different, and it's acute because every single angle, all three of them, are acute. Moving on to the example 2 here, just pretty much with every one of these examples, there's going to be something missing. So right here, that is missing. Okay, so let's set up a simple equation here to figure this out. So we've got x plus 33 degrees plus 29 degrees. And we're going to set that equal to 180 because that's what we know triangles always add up to. So 33 plus 29 is going to be 62. Okay, so I got 118 degrees for that angle that is missing. So what does that make that? That makes that triangle, since this is 118 degrees, those are acute, but there's one obtuse angle, and that's all you need to make an obtuse triangle. So that's an obtuse triangle. And if we look at its side lengths, we're just going to compare, okay, we've got 20 feet here, we've got 18 feet here, and we have 27 feet there. And though all the side lengths are different. So that is scalene. And really, like I was saying earlier, if you know that all the angles are different, all the side lengths will be different. There's always a correlation there between the side lengths and the angle measurements. If the angles are all different, I can guarantee you the side lengths will be different, and vice versa. Now diving into example 3 right here, we're missing 2 angles on this particular one. So we have two angles that are missing. So what we do have, though, is we have two side lengths that are the same. So what that means is that this is definitely isosceles. That's an isosceles triangle. Now, knowing that that's an isosceles triangle, those angles right there should be the same. So I can make those both x. We can make those both x, and then we can set up our equation. So we've got x plus 76 equals 180. And the reason we can make these both the same thing is because we know that they have the same measurement. We know that this one, whatever this is, x is, that's going to be the same thing. So x plus x is 2x plus 76 equals 180. So I got x equals 52. So that angle right there is 52 degrees, and that angle right there is also 52 degrees. And if you're unsure about that, just add them all up. 52 plus 76 is going to come out to be 180 exactly. Now, what is this triangle based on its angles? Well, let's look. We have an acute angle here. 52, those are both acute. 76 is also acute. I'll write it over here. And so that's definitely an acute triangle because every single angle is less than 90 degrees. Moving on to example 4. Now, based on its angles, you can look at this and go, well, every angle is 60. Every single angle is acute. So that's an acute triangle. And then if you're looking at the side lengths, you might notice, well, I'm only giving you one side length. This side length right here is missing, and this side length is also missing. But remember what I said. If angle measurements are the same, I guarantee you the side lengths are also the same. So if this is 25, everything is 25 feet. And this is also going to be 25 feet. If we were to classify this triangle by its side lengths, this is definitely equilateral. Now here's another thing. That we can also say that this is isosceles as well. If I go back here a little bit, if I look at the definition of what makes an isosceles triangle what it is, it says at least two equal sides. Now, at least means it could be 2 or it could be 3. At least does not say only 2 equal sides. It says at least 2 equal sides. An equilateral triangle is also classified as an isosceles triangle. And I know that seems really confusing, but it's isosceles because this has at least 2 equal sides. Those two are equal. Well, so is that one, but it's both. Now, if I said, just give me the most specific description of that triangle, yeah, most people are going to give equilateral. But if you said isosceles, you would not be incorrect. Now just pause the video at this point and just give this one a try. And then when you're finished, unpause the video and see what you get. Okay, so now that you're finished with this problem, you should end up with what I have here. I'm calling this an obtuse triangle. And the reason it's obtuse is because the angle that we found was an obtuse angle. Now I know these two angles are acute. That is important. However, what's most important is that the third angle is obtuse. 108 degrees is greater than 90. That makes it obtuse. So that is definitely an obtuse triangle. Obtuse triangles are always going to have one obtuse angle, and the other two will always, every single time, 100% of the time, will be acute. There was no numbers here given for the side lengths. There was only hash marks shown. Well, those hash marks are all different. There's 1 here, there's 2, and there's 3 here, which indicates that we're talking about different side lengths. Now here, before I move on, I just want to talk about another thing that's kind of interesting, and it doesn't really apply yet today to today's lesson, but I just want to kind of throw it out there because you're going to see it. And one thing I want you to notice is that if you look at the angle measurements, and then if you look at the angle, or not the angle, but if you look at the side length that is directly opposite of that angle. So 108 is directly opposite of that segment. Now you might want to notice that 108 is the largest angle. And now what else do you notice about the segment? That's the largest segment. And that is pretty much, well, that's not pretty much, that's always going to be true about triangles as well. If you find the largest segment, I guarantee you the largest angle is going to be opposite, and vice versa. The largest angle will be opposite the largest segment. And look right here. That's the smallest angle right there, and that's directly opposite. I know I'm getting a little bit messy here, but that's directly opposite of this segment, which is the smallest segment. So 35 degrees being the smallest angle, and this right here is the smallest segment. And that's always going to be true. For this third part right here, you're given 3 side lengths or 3 angles. Sometimes you're only given lengths, sometimes you're only given angles, and sometimes you're not given enough. You might notice like right here, there's a number missing. Right here, there's 2 numbers missing. And that doesn't mean there's missing information that you can't figure it out. That means you can figure it out. You just have to use a little bit of critical thinking and problem solving to figure it out. When you're done going over these, why don't you go ahead and unpause the video and compare your answers to mine. Now 35, 49, and 96, that has one angle in it that is obtuse. So I wrote down that's an obtuse triangle. Now the classifying by its side lengths, you might think of course, well, we're not given side lengths, we're only given angles, but that's enough information to figure out. If you notice all the angles are different, so you can guarantee all the side lengths are also going to be different. So that's a scalene triangle for sure. On the second one here, we've got 13 and we've got 13 twice, and we have 19. So that, if we classify that based on its side lengths, that's an isosceles triangle. And then if we try to classify that by its angles, I wouldn't be so sure on that, because just because we have 2 angles that are the same, or just because we have 2 side lengths that are the same, doesn't mean we know enough about the angles. So that one right there, you might have been scratching your head going, there's not enough information. I mean, I guess you could if you can use some basic, well, it's not basic, but if you use trigonometry, which is something you're going to learn in high school, probably sophomore year, you're going to have enough information to figure that out, but you don't need to use law of cosines to figure that out. Now the third one right here, we have a third angle that's missing. Well, 39 and 51, that makes 90. So that means this has got to be 90 as well, because 35 plus 51 plus 90 equals 180. Now that being 90 degrees, that makes that automatically a right triangle. And then if you notice, all the angle lengths are different, so that means all the side lengths are different. So it's a right scalene triangle. Now this one has all the same side lengths. Well, if it has all the same side lengths, that means it's definitely equilateral. And if it's equilateral, it's definitely going to be acute. There's no way an equilateral could be obtuse. There's no way it could be a right triangle. Equilateral triangles will always be acute. And then right here on this next example, we're given the information that it's isosceles, which tells us that these 2 angles right here have to be the same. Those have to be the same. So if I do a little bit of math here, well, 180 minus 118 gives us 62 degrees. Now that does not mean this is 62 and this is 62. What that means is those 2 together are going to be 62. So what's 62 divided by 2 is 31. So those are 31 degrees right there. And then all we need to know is that that is going to be that is definitely an obtuse triangle. And we really didn't even need to know that that was 31 and 31, but that's obtuse for sure. Now this one right here, we have 2 60-degree angles. I'm not sure if this is how it was given on your note sheet, but if that's 60 and 60, well, then this one has to be 60 as well. And so that is acute. And is isosceles, and it's also equilateral. All equilateral triangles will be isosceles. All isosceles triangles are not equilateral though, but you can definitely go in that direction where equilateral are isosceles. Okay, so that does it for your lesson, everybody. Hopefully this wasn't too confusing and you guys all got it. Make sure you guys do the IXL that accompanies this lesson. And please, please, please let me know if you're having any difficulty with this and I can get a hold of you and we can go over it. Okay, everyone have a great day. See ya.